Alright, hey guys, this is Wednesday, April 1st. So, I hope y'all are doing well with it so far and everything. So we'll just kind of keep moving along with it. Now, a couple things here for today. We're going to be doing something a little bit differently than what we've done the past couple days. And so just pay close attention and we should be okay. It basically moves forward pretty simple once you get the hang of it. And so this is going to be over on page 511. And this section is on dilations. And so if you look at the definition for a dilation, which I wrote on the left side of the board here, it's also in the book on page 511, it says a dilation is a transformation that expands or contracts the points of the plane in relation to a fixed point P. And so all that happens is, basically you have your original shape, which we should know by now is your pre-image. And so we have our pre-image, our triangle here, A, B, C. And then we have a point P on the outside here. Now, the point P can be on the inside of the shape, it can be on the outside of the shape. It doesn't really matter. All that really matters is that it's going to either make our shape bigger or make our shape smaller, depending on how the orientation is. And so in this case, our point P is here. So you see if we extend P, the lines of P out, then our B is going to become B prime somewhere down here. And then our A is going to become A prime somewhere out here, and then it makes our C become C prime somewhere out here. So you notice what happens is your original pre-image is basically either going to get bigger or it's going to get smaller depending on how it's done. And so in this case, this one got bigger. And so we took our pre-image and then we enlarged it to get our bigger image, which is A prime, B prime, and C prime. And so that's the definition. So essentially all we're going to be doing is we're going to have a shape or some type of plane, which is a shape, and we're going to make it bigger or smaller. And so essentially that's how that works. Now, a couple different things here with the rules. If you look on page 512, at the very bottom of the page, basically it talks about K. Our K is going to be the measure that it increases or decreases. It's going to be the ratio of increase and decrease. And so in this case, if K is greater than 1, meaning if that number is bigger than 1, it's going to be an enlargement. And so here, I could just look at this, glance at it really quick, and I would know that, I don't know what my K is, so I didn't put in the measurements, but I know that the K would be greater than 1 because we took this image and we got a bigger one. And so that is going to be an enlargement. So when K is greater than 1, it's going to be an enlargement. When K equals 1, you're going to get the same figure back, and so it's not going to change. So when K equals 1, you're going to get the exact same figure back, and that's not going to change at all. And then when K is less than 1, it's going to be a reduction. And so when K is less than 1, that is going to be a reduction. So a couple things on this, just to kind of make sure we're clear with it. Notice the enlargement is going to be greater than 1 and the reduction is going to be less than 1. And so we can just kind of think about it in terms of that pretty easily. And then when K equals 1, it's not going to change. So what we can think about is, when will I get the same figure back? When will I not get the same figure back? And in what cases would these be similar triangles or will they be congruent triangles, and how that's going to work? Remember, congruent triangles are going to have the exact same measure. They're going to have the exact same everything. And so if you notice, these two triangles are going to be similar, meaning they're going to be proportionate to each other, but they're not going to be the exact same figure. They're not going to be congruent. And so, for example, if we took the area of this triangle, obviously we're going to get a smaller area than the area of the bigger triangle. And so one note you may want to make sure you get clear here is that the two planes, the two images, are going to be similar, meaning they have the same ratio and everything, but they're not going to be congruent, which means the sides are going to change. And so they're not going to have the same area or anything like that, or the same perimeter, but they will be similar. They'll be proportionate to each other. And so that's key. And so we'll move on to our type of problem. So if you look over here to the right of the board, so the question is, what is K? K is basically the ratio between one side to the other side. And so to get our K for this shape right here, I'm going to take the distance of A prime, B prime, the final one, the actual image, and I'm going to divide that by the distance for the pre-image, which would be AB. And so that is going to give you your K. And then if k is bigger than 1, it's an enlargement. If k is equal to 1, it's not going to change. And if k is less than 1, it's going to be a reduction. So if I look up here on this problem up on the board, I said that the distance for AB, the original image, was 10 centimeters. So when I go to find k, the bottom number will be 10 centimeters. Okay? Now the top number is going to be A prime, B prime, that distance. And so that distance became 20 centimeters. And so this is 20 centimeters. So k would equal 20 centimeters divided by 10 centimeters. And so when you do that, your k is going to equal 2 or 2 centimeters. And so k would equal 2. And so for this problem, since k is larger than 2, k is greater than 1 since it's 2, then that's going to mean that this is an enlargement. So this is an enlargement. So if k is greater than 1, it's an enlargement. If k is less than 1, it's a reduction. And if k is the same, and if k is equal to 1, then that means that the two images did not change. And so that is essentially how we're going to work through those. Now, one thing to kind of take note of is I just labeled AB and A prime, B prime. Since these are actually similar triangles, you could have done any side you want to do. Because basically what's going to happen is it's going to wind up being the same ratio. And so for example, if this side right here was 15, then if BC was 15, then B prime, C prime has to be twice that since K is 2. So it would be 30. And you can fill in the other ones the same way. And so if you have all the measurements, you just need to pick one side and then do the ratio fraction. And so I could have done BC, would have been 15, and then BC prime would have been 30, and then you divide and get 2. So just know that you don't always have to do AB. If they give you other measurements, you can use those, but the measurements have to go together. So if you do AB here, you have to do A prime, B prime here. If you do B and C here, then you have to do B prime and C prime there. If you do AC here, you have to do A prime and C prime. So you have to do the two that go together. But outside of that, it's just working through it the same way. Okay? So basically that's how the problems are going to work. They're going to give it to you like this, and you'll have to find K. Another option they could do is they could give you one of the sides, like I just kind of went through there, and you'll have to find the other one. And so if they say that K equals 6, so they say K equals 6, and they give me that AB is, we'll say, 3. And then they're going to ask you for what is A prime, B prime. So what is the dilation? What would this measurement, what that distance actually be? And so if that's the case, all you're going to do is multiply your K times the distance they give you. And so if they give you that the K is 6 and they give you the original pre-image, then you're just going to do 3 times 6, and then that'll give us our A prime, B prime being 18. And so since 3 times 6 is 18, A prime, B prime would also be 18. And so that's going to be how you go through those. And so the question is, how would you make one, say, smaller? Say we have a larger image and we want to make it smaller because all these I've done have made it bigger, enlarged it. All that would happen would be if they said that K was 1/2 and our AB was, say, 40, then what would my A prime, B prime measurement be? And so in this case, you're going to take 40 and divide it by 2, or multiply times the 1/2, and you would end up with 20. And so my A prime, B prime is 20, meaning whatever this side is going to get smaller. And so we're going to take the big side of 40, and our next image is only going to have one of 20. And so basically the fraction is going to be the one that is less than 1, because the fraction is less than 1. And so the fraction is going to tell you that your image is getting smaller, or it's a reduction. If K is a large number, obviously, then it's going to be an enlargement. And again, if your K equals 1, it's not going to change and get the exact same image back. And so if you look with me real quick, that should be enough to kind of get y'all started. Look at well, I'll do, look at number 1 and 2 on page 513. So this is important because you need a ruler. I'm going to actually give you the measurements, so all you have to do is the math. So you need to pay attention right here for the homework so I can fill this in for you. So number 1, I need you to do the measurement for A prime C prime is 24. So 24 is the measurement for A prime C prime. For A and C, it is 9. So AC is 9. So the measurement for A prime C prime is 24. The measurement for just AC is 9. So you need to fill that in. For number 2, the distance for A prime B prime is 20. So the distance for A prime B prime is 20. And the distance for AB is 13.5. So 13.5 for AB, and A prime B prime was 20. Now, for number 3 through 8, you're just going to be getting basically what the new one would be. And so, one thing to keep in mind is if you go from, we'll do one like this too, just real quick, just so you can kind of work through it. If they give you A prime, B prime, it's say 20, and they want to know what AB is, then you have to keep in mind what you're actually doing. And so if they give you AB, you just basically multiply by whatever this number is. But if they flip it around and they give us the A prime, B prime, then that means you want to actually multiply by 2 because you're wanting to go from the new image to the one that you started with. And so A prime, B prime is just going to be work the opposite way. And so I would multiply by 2 because I'm dividing by 1/2. And so it would be AB equals 40. And so there are a couple like that where they actually give you the final image and they want to know what the distance would be on the pre-image. And so in that case, you just do the opposite. So if this was another one like that, real quick, before I move on, if K would equal, we'll say 6, and AB prime was 30, then you would want to take the 30 and divide by 6 since you're wanting to get to the original pre-image. And so AB would be 5. Remember, whatever this is, you multiply by to get that. And so if they give you this, you have to divide by that to get back down. And so that should help you out with 3 through 8. And then the last few I need you to do is also 9 through basically 15. And so again, 9 through 12 are telling me whether it's an enlargement or reduction or the same. So you have to know what your K is. And then for 13, 14, and 15, for 14, you need these numbers, so pay attention here. So for 14, X prime, Y prime is 8. And for X, Y, it's 19. So X, Y is 19. X prime, Y prime is 8. And then for number 15, your AB is 5. And your A prime, B prime is 8.5. So A prime, B prime is 8.5, and AB is 5. And so that should help you out so you don't need a ruler for those. Again, technically what you would do is you would take the ruler and measure those segments and get the measurement I just gave you, but we'll skip that step for y'all right now. And so that should get you through to the homework. Hope you'll have a good day. Have any questions, get with me.